All right, hey there everyone. We are getting started on logarithmic differentiation. Okay, pretty straightforward. There's some very useful tricks that come along with this skill. So we're going to just start off by considering, suppose we have some simple equation here and it is just bare bones minimum, okay, like that. We've got y equals log base a of x, and we're going to differentiate this. What is it when we go to take the derivative? Well, here's where implicit differentiation comes in handy, because we can rewrite this by getting it out of log format and by saying, well, this is the same as x equals a to the y, right? So our basic definition, cover up the log, bring that over, this is the base, that's the exponent, it's equal to x, and now we can take this and differentiate this implicitly, all right? So if I do this, d dx, the derivative with respect to x of x, and then the same thing over here, d dx of a to the y, well, this is just going to be 1, all right? And then what is this? Well, if you remember, when we differentiate this, we are going to get a to the y, then times the ln of our base there, a, okay? But that's the derivative of the outside, not touching the inside, all right? There that is. And then it's times the derivative of the inside, y prime, okay? Remember, our goal is to get y prime. So then I know that this is equal to then 1 over a to the y, ln of a, all right, like that. But remember, a to the y is just equal to x, so y prime then is just equal to 1 over x ln of a, all right? So this is our sort of generic formula, but if we have a choice as to what log we use, what base we use, we're going to make that base e, all right? So then we would just have the ln of e, which poof goes away. So a very important relationship is that if y equals the ln of x, then dy is just 1 over x, okay? So you are going to use this an awful lot, all right? Anytime we're taking the derivative of a log function, we just can take and put 1 over whatever is inside that, all right? So this is extremely handy when we go to solve some complex problems, right? So I need to do a little example here, and I'm going to just put like a random problem up on the board here. Suppose we had y equals, let's say, x to the third all over 1 plus 5x times the fifth root of something ugly like x to the fourth plus 3, okay? If we're going to take and take the derivative of that, we could do it old school, which would be a quotient rule, and then when we do the derivative of this, we have a product rule, so it would wind up taking an awful lot of space, all right? And it would take us, I don't know, maybe half an hour. But by using logarithmic techniques, we can break it down and do it much, much more quickly. What we do then is we just take the log of both sides. ln of this side, ln of this side, okay? And then we've got those laws of logarithms that allow us to break this apart, all right? So on this side, we've just got the ln of y, but on this side, when we undo it, I've got the ln of just the top minus the ln of the bottom. And remember, every exponent we can just bring out front. So with a little bit of practice, you guys are pretty good at this before, I can make this 3 ln of x. And then it's going to be minus ln of 1 plus 5x. And then I could put these all in parentheses, or I can just distribute the minus sign. So I can make this minus 1/5, then ln of x to the fourth plus 3. Okay? Hope that all fits. I'll move it over a little bit. Then what I can do is I can differentiate each side. Well, the derivative of this is just going to be chain rule. Derivative of ln of y is 1 over y times the derivative of the inside, which is y prime. Then this is going to be 3 times the derivative of this, which is, just remember, it's 1 over x, put that down below, minus, again, the derivative of this is just 1 over the inside, then times the derivative of the inside, which is 5, so I'm going to make it that, and then minus 1/5, again, it's 1 over x to the 4th plus 3, then times the derivative of the inside, which I'm going to make into 4x to the 3rd, okay? Now I'm not done because I need to get y prime by itself, but I just simply multiply both sides by y, and that goes away, and I get y prime, and then I just get this whole thing times y. Well, we know what y is. We were told that in the beginning. It's just this whole expression here, which for all intents and purposes we don't need to rewrite again, but it's going to be x to the 3rd all over then 1 plus 5x, and then the 5th root of x to the 4th plus 3. All right? So it's long and it might be ugly, but it's fast and it works. And if you need to evaluate it, you can do that. All right? It saves you all of the time of spreading it all out using quotient rule and product rule and taking a long time to get an equally long or even longer and uglier expression like that. There you go. It's a good start.